Hi class, this is Mr. Cheng. I'm going to do lesson 2 again. Just highlight the difficult example and then do some homework together. Alright, let's go to this page, page 72. And then these are some example which you need to combine exponent law. So make sure you know exponent law and then you can work on this chapter. So this is some basic skill. You need it in grade 11, grade 12, when you work with math. Whenever there's math expression, you need to know how to work with them properly. So let's look at example 3. Basically, let's start with the basic one. If you read this expression, this is one term. However, it has different parts. It has a number part, which is called the coefficient, and also you have the variable part. In this case, you have a power of 2, so this is a power. Well, the rule for cubing 3, a number, and a power is different. When you cube a number, you just cube it, put it in a calculator. When you cube a power, this is called a power, you need to use exponent law. Powers on powers, you multiply the exponent. Okay? Here, same thing. Negative, so there are three things here. The sign, negative, positive, the numbers, coefficient, and then the variables. These are all powers. So what do when you square them? When you negative square is positive, you don't need to write positive, but I just put it here to emphasize it's again positive. 2 square is a 4. A square square, you multiply the exponent. And then b cubed square, you multiply the exponent. Okay? So we did this example in class. So let me move on to the harder one. Example number 4 here. Second one. I have something to power 4. Well, if you look in what's inside, I'll suggest you simplify the inside first. Okay, so you leave the 4 there. Let's simplify the inside. Let's deal with the number first. 4 times 3 divided by 6 is a 2. All right, now deal with the variables. Well, let's do them in alphabetical order. x6 over x5, divide x power, you subtract the exponent, become x1. You don't need to write 1 here. When you don't write anything, it implies 1. How about the y? Well, there's nothing there to change the y, so it's remain y cubed. Finally, let's bring everything to power 4. Number, you put in the calculator, becomes 16. But then for the power, you use exponent law. This is basically x1. 1 times 4 is 4. This is 3 times 4 is 12. Okay. Let's try part C. So why do I pick C? Because here, the square only applies to these two parts here, not 16. So you can just copy the 16 there. And let's deal with the number here. Powers on powers. x6, y10. Now here, the 2, you can't cancel with the 16 yet because it's inside the bracket with a cube. You need to deal with that first. 2 to the power of 3 is 8. And x squared cube is x6. Now you have removed all the brackets. You have removed all the exponent on expression. Now you can just deal with the number. 16 and 8 is a 2. x6 is disappear. Well, if you use exponent law, x6 divided by x6, you subtract the exponent. x6 minus 6, which is x0. So what is x0? x0 is 1, which means you don't need to write it. You just times it by 1. It remains the same. Finally, the y10, you just put it there. Okay, let's move on to other example. Okay, I'll just pick one from each example. Now, question 5, I actually think this is a difficult example. Why? Because you can see the base here are different. One is a, one is negative a. Well, they say they are very much alike. Well, but they are not the same, right? One is positive a, one is negative a. Well, how about this negative? Well, this negative is outside the exponent. So the power is a6. And this one, the power is negative a4. And then our exponent law doesn't work if the base are not the same. So you need to change the base until they're the same. Okay, so here you cannot apply the exponent law yet. You need to solve this part first. So power negative to the power 4 is positive, and a4 is just a4. Okay, now this is good. This is just like that. right? So the now you can use exponent law because the base now is the same. Again, the negative is just the sign of the term is on the outside. A6 minus A4, divide by A4, you subtract the exponent. Here we go. Okay, let's try example number 6. Okay, there's a lot of terms here, but you need to do bad miss. You need to take care of the bracket and exponent first. So which means I need to do this part and I need to do this part. So how about the rest? The rest you just copy them. Okay, so for now I'm not working with those part yet. Okay, now I'll just deal with the brackets part. Negative to the power of 4 is positive. Z2 squared is Z8. Powers on powers you multiply. Here, 2 to the power of 3 is 8. So put a dot here so you know you're multiplying. It's not 68, it's 8. And then x3 and then y6. Okay? Now let's simplify, continue our simplification. So let's work with the number. 72 divided by 8 is a 9. Okay? So this term are gone within a 9 and 6. Well, there's common factor. You can divide by 3. Divide by 3. Divide by 3. So the number becomes just 3 and 2. Okay? 3 and 2. Let's look at the variable. x4 minus divide by x3. So you subtract the exponent x1. y10, y3. Oh, there's another y6 here. You can combine these two first. y6, y3 is a y9 in the bottom. y10 divided by y9 is 1y. Finally, this cancel out. Remember z0, that's just 1. So that's the answer. Okay, the challenge of this example is here is power on power. You multiply the exponent. After that is division or multiplication. You add or subtract the exponent. So you're switching the operation on what you do to the exponent according to the exponent law. Everything is consistent, but you just need to do this carefully. All right, let's do some homework together. I'll only pick the difficult one. So let's pick number 6 and number 7. Okay, number 6E. All right, this one, 6E. Okay, I picked this one because now the cube is in the this part here. So you need to deal with that first. Here, the bracket is, since everything is just multiplying, right? This all imply multiplying. You can just like write them here. So I'm not changing them. Now let me change this part here. So let me use a different color. 3 cube is 27. And then you cube everything. Okay, so there's a power. So you multiply the exponent. A3, B3, C6. Okay, so power on powers you multiply. Now powers times power, you add the exponent. See, you're switching what you do with the exponent. So that's the source of error. Number, usually you put in the front. A3 is a A6, you're adding the exponent. B4, B3 is B7. Finally, C11. All right, question 7. Okay, question 7. Oops. Question 7. So I just want more space here. Question 7. All right, what do we do? First, you see there's a square here, so I need to deal with this part and then square it. There's some common terms here. I can simplify it first. And also there's another bracket, so let me deal with that. Okay, first, inside the square. Okay, so I'll just copy the part that I'm not working with now. So these are the part I'm not working with, and I'm working with the color part here. Negative, let's deal with the sign. Negative, remain negative. Let's deal with the number. There's only a 5 there. There's a 5. Let's deal with the variables. K3, K2, you add them, K5. And then divide by 1K, so that's K4, right? 3 plus 1, 3 plus 2 minus 1, K4. Here, I'm dealing with the brackets. Negative to the power of 5 is negative. K to the power of 5 is 5. Okay? So that's the first step. The red part is the part I didn't touch. Now let's simplify it. Next step, let's deal with this one. You square this, become 25K8. Power on power. The negative is become positive. Here, let's deal with this whole thing. Negative remain negative. Okay, the 5 remain in the bottom. K2, okay, the K2, K2 cancel out, leaving a K5. All right, finally, what do we do? Numerator, denominator, leaving a 5 there. the negative sign, so we put in the front, -5, right? This is a 5. Now let's look at the k. K, you add them. Okay, so this is the answer. The difficulty is you switching between adding them, right, to multiplying them, and then you adding the exponent again. You're switching between exponent law. Okay, let's look for more example. Do we have more challenging question? So now we're working with some numbers. You can try them, working with all that. Okay, so you can give that a try. Let's try numeric response 12. Last example. So they say this expression can be simplified to that. Well, we'll ignore the form part for now. We'll just solve this. Okay, so what are we going to do? We want to simplify it. Okay, let's simplify it. So I need to square first, and I need to cube. Okay, so let's square. -3 square is a 9. M square square is a 4. N3 square is a N6. So that's the first part here. Now the second part, you see the cube here. -2 cube is a -8. M3 cube is M9. N cube is N3. Okay, all divided by 1 over 27, all multiplied by that. So it doesn't do anything, right? It doesn't change anything. You just copy that over. Now let's deal with the numbers. First, the sign is negative. Okay, negative. Next, the number. 9 times 8 is 72. 72 divided by 72. Oh, it's just 1. Okay, so no number. All this cancel out. Now let's deal with the variables. M4, M9, so you add them, M13, and then divide by M2, you minus 2, M11. And now looks at N, N6, N3, that's N9, and then N3 in the bottom, minus 3, that's N6. Here we go, that's the answer, okay? So that's my answer. Now let's read on. It says the question is in the form of A, M, B, and C. So let's equate A, B, C. Well, obviously, C is 6, B is 11. You need to match the form. You need to match every part. N match with N, M match with M. How about A? A is -1. Okay, you don't need to write 1, but if I ask you what's A, I would say A is -1. You won't say A is negative. Negative what? -1. Okay, so that's ABC. What do they want you to do? They want you to add them. Okay, so that's the characteristic of numeric response. They just want you to do something about the answer. It has nothing to do with the question, A plus B plus C. They just want you to play with the answer that you have. Okay, and I just add A. A is -1 plus B is 11 plus C is 6. So the answer is 16. You put it here. From left to right, you put 1, 6. So that's the answer. All right, so I've done most of the question homework, and I hope you will find it useful. And thanks for watching. Remember, math is awesome.